We're excited to announce that our very own podcasting platform, Zencastr, has become a new sponsor to the show. Check out the podcast's discount link in our show notes and stay tuned for why we love using Zen for the podcast.
You're listening to the Archaeology Podcast Network.
Hi, welcome to the Architect Podcast, episode 118. This is Paul Zimmerman. Chris could not be here today. He's stuck in transit somewhere, so he'll hopefully be back next time. I was going to say I'm flying solo, but I'm absolutely not flying solo because we have a nice interview lined up for you today with Kelsey Reese. Kelsey is a Ph.D. candidate in anthropology at Notre Dame and recently published a paper in American Antiquity alongside her co-authors Donna Glowacki and Timothy Kohler entitled Dynamic Communities on the Mesa Verde Cuesta. We're going to discuss that and some of Kelsey's ideas about tech and her use of it in archaeology. But before we start, actually, Kelsey, what I want to say is 2 weeks ago, we interviewed Sean Field, and we had a very nice discussion about the GIS work that he was doing in and around Chaco Canyon. And afterwards, off air, we were having a little chat, and we said to him, well, you know, if you know anybody that you think would be good to come on the show and talk to us, please let us know. And he said, oh, yeah, absolutely. You have to talk to Kelsey Reese. So we said, hey, you know, she's already signed up. This is perfect. So I guess we're trolling Notre Dame this month. But Kelsey, how you doing?
I'm doing great. And thanks to Sean Field, you know, that's what good friends are for, to give you a good word. But it's great joining you today. And thank you for having me.
You know, we're really happy to have you. This is an interesting article that you wrote. Do you want to give us an overview for our listeners, what the article is about? And then we can go into some of the details about how you did your work and what some of your findings were.
Yeah, this article is basically a product of my master's thesis that I completed in 2014 at Washington State University. The idea of it was to basically try to find an emergent extent of community interaction in the northern U.S. Southwest by using changes in spatial patterns of households through time. Mm-hmm. And so this whole idea kind of came about as we were all sitting doing field work out in Mesa Verde National Park. And, it would take us hours to get to our sites in the backcountry. And we'd be sitting there on our breaks and thinking about the realities of living in that landscape and how difficult it really would be to interact with your neighbors or other households if you were living in those spaces, and how you might try to counteract that by, you would choose to live closer to the people that you really wanted to interact with on a regular basis, because otherwise it would be pretty, not impossible, but there would certainly be large impediments to that interaction. And just to point out for those not familiar with the Mesa Verde Cuesta itself, it's kind of this series of mesa tops and canyons, and they vary greatly in elevation. So you basically have all these finger mesa tops running north-south, and then they're all bordered by deep canyons or valleys. And so if you were living on one mesa top, it would take a lot of effort and a lot of investment to regularly interact with the people on a neighboring mesa top. As the crow flies, they may only be 1,000 meters away, but it might take you twice as long to actually, go visit those people. So the idea was that if we could assume that those people were actively choosing to live closer to each other if they wanted to interact, then maybe we could identify kind of those self-delineating extents that they were willing to travel through time to maintain those relationships.
Right. So practically speaking, if you're in community A and you wanted to get to community B, you might have to go down a cliff to cross a valley to climb another cliff to get to that community. Is that basically how it would work?
Yes, absolutely. That is a very clear way of saying it.
So you'd more likely be interacting frequently with people who also lived on the same mesa top.
Right, exactly.
And then you have developed a number of statistical computer techniques to try to model that kind of behavior.
Right. So the whole idea was trying to, again, come up with this like emergent extent, and in doing so, trying to remove my bias as a researcher that, might just draw circles around clusters of what I see as, maybe they might be interacting or whatever. And so it was trying to remove that bias as much as possible to produce extents that were just purely a result of where those data points were landing through time. And really this type of analysis was really possible because of a larger project that I was part of called the Village Ecodynamics Project. And they worked for years and years and years to collect, site data all across the northern U.S. Southwest in the Mesa Verde region. And then a couple of researchers, originally, there's an article also in American Antiquity, Ortman et al., 2007, which produced a Bayesian analysis to date sites based on their surface ceramics. And then a follow-up to that, which is Schwint et al. In 2016. And those two papers were actually, they created the data set that I was able to use, and that dated households to very specific time periods. We have one time span that's, I think, only 20 years long. Most of them are about 40 years long. And so we were able to really parse out, very specific movements. We just had a really high resolution time data to come out with these patterns through time. So the data itself really lent itself to this type of analysis. Yeah. But as part of that, and in using that data, basically to come up with these clusters or these communities or potential communities, I created a null model, which basically put a bunch of random points on the landscape and said, with the idea of, okay, if somebody was moving into this landscape completely at random and they weren't thinking about where their neighbors were living or whatever, what would that look like? Mm-hmm. And then of course we can look at the difference between that and the actual spatial patterns that we see in households. And they're different, which we expect to see, right? We were like, yeah, of course they're different, because people do consider other things when they consider everything when they move into a certain space. But we were able to, basically quantify that difference, quantify that social, environmental, political, whatever those influences are. That's what changes the distribution that we actually see from the null model.
Right. So rather than an even random distribution across the landscape, you have some kind of clustering, and you're trying to get at the reasons for those clusterings. Right.
Exactly. Just from the null model, then based on those results, I basically ran a cluster analysis that it's called affinity propagation cluster analysis, which is this really specific type. And it was chosen because you actually do not have to put in an input telling the algorithm how many clusters you want. Mm-hmm. And so again, it's this whole idea of like trying to take the researchers' biases out of the analysis itself. And so that cluster analysis basically goes out and looks at the data and finds the ideal number of clusters for the data that you give it. And so then that would be how many communities end up popping out at the end.
Let me, since you used the word communities there, let me back us up a little bit, and I'm going to step us back up to that term. How big is this area that you're looking at?
So Mesa Verde National Park, oh gosh, this is a good pop quiz. I think
Sorry.
I think it's about 210 square kilometers. Okay,
and about how many different households are you looking at there?
It varies through time. Mm-hmm. We go from about, let's see, at the lowest, I think we have about 70 households. And so we're using the term household, which is very mushy in Southwest archaeology. So it's this idea that it's a family unit, but there's a lot of different numbers out there of what a household actually represents. So in the paper, we kind of average out that range of ideas. So the lowest end is 3.3 people per household, which is a result of some modeling of one of my co-authors, Tim Kohler. And then the higher range is 7 people for that household, which is, from other literature and stuff. And so we average that out to create like what the household is itself, gotcha, or what we think about it. Yeah, so the lower end is about 60, 70 households. And then at the higher end, we get over 400, I think 460
Wow.
something. Yeah.
And then, if I recall correctly, what your household is primarily architecturally based, right? That's what's defining it, or is there other kinds of sites that help you define what a household is?
So I try to make the distinction in the paper, and am careful about how I use the term household versus residence. The residence is basically the physical architecture on the ground that has, X many number of rooms, and that will tell you how many households likely occupied that space. And then the household being that social aspect representing actual people. And I have probably conflated that this entire time so far in this conversation. But yeah, really it's all just the number of residences, or the number of households, is based on the number of residences that we see in the archaeological record.
Gotcha. And then the time period that we're looking at here, you're looking at between 600 and 1200 roughly.
And that's 600 and 1280.
Yes.
Yeah.
And that, I should have specified. I normally work in BCE, so 612, I guess the order that I said it would have made sense. And then that comprises a number of different, my specialty is not the Southwest, so a number of different cultures. Is that the term still used between Basque Maker and Puebloan?
Right. So they're all ancestral Pueblo. It's all the same group of people. It's more kind of just defining like a typical set of characteristics. So, your Basque Maker 3, you're getting early pottery. People are typically living in subterranean pit structures. And then you have your transition into Pueblo. So it's called the pit to Pueblo transition, where people are starting to create masonry structures above the ground, but then they still have pit structures that they're using associated with that. And then the Pueblo II period, you're getting larger, more aggregated communities. You're getting kind of large, more substantial architecture, using larger masonry stones. And you start seeing a more formalization of your pit structures. And then that's when they start kind of turning, or being referred to as kivas, which have ritual connotation. Right. So I typically stick with the model of just referring to them as pit structures, so I'm not putting any meaning on there that may or may not have existed. But and then into the Pueblo III period, you're getting an increase in population. You're getting even more aggregated communities, larger structures, and then of course the move into the alcove sites, which is where you get your classic cliff dwellings of Mesa Verde National Park. So it's all the same people. It's just, they're going through a lot of changes and development and, figuring out different ways to kind of live and interact in the same space.
All right. So the residences are indicators of the households, but they're not the households themselves. And the shapes of the residences changes through this 600 years of span of time.
Yes.
Okay.
Yeah, exactly.
That's a lot to try to tease out. You are using these to then look at communities, which you are looking at changes then of time through time of communities. What do you define then as a community in this project?
Right. So we define a community based on a definition that has been used for a very long time in Southwest archaeology, and is initially based on a definition in the, let's see, I have the book. The book is called Social Structure, George Murdoch. And so it's this idea that a community is a group of people that you are interacting with on a daily basis. And if not a daily basis, you have the opportunity to interact with on a daily basis.
Gotcha.
And so if you're going to be interacting with people very regularly without the, modern wonders of, cars and planes, you're really just left with your feet. And so that's why it has such a large impact on how these households of people are organizing themselves.
So as you hinted earlier, it's easier to get to be in regular contact with somebody that's on the same mesa top as you versus somebody on the next mesa over. And so that's part of how you define what a community is. And you're doing that through computerized GIS techniques, such as what was done on our last interview, what Sean was doing with cost surfaces.
Right. The least cost analysis that we did in Mesa Verde National Park, like I said, it's built of this series of mesa tops and canyons. The cost surface is going to have a huge impact on the paths that people take to interact with one another. And so, like I said earlier, you can have two households that are maybe only 1,000 meters apart, but it might take much longer than that for those people to actually interact with one another. So in the clusters of households that we get in our results, in a lot of areas, you'll see that the households actually cluster right on top of mesa tops. Now, there are plenty of instances where that's not the case, and you actually get households that are clustering, across canyons or valleys, which is kind of an interesting result. But really, I think it's a product of the data that we have. So the spatial data that we have in the household data is limited to the borders of Mesa Verde National Park. Now, while that's a large area, it only is about 1/3 of the entire Mesa Verde landform, or the Mesa Verde Cuesta landform. So I think a lot of when we see those types of effects, it's kind of like an edge effect. If we had data of households across the entire space, you probably wouldn't get that happening as much.
So why don't we go to break, and when we come back, we can dive in a little bit more to some of the tools that you use and some of the techniques that you applied them to try to get these clusters and these communities, and what that was showing you about the change in how people lived in that landscape through time.
Chris Webster here for the Archaeology Podcast Network. We strive for high-quality interviews and content so you can find information on any topic in archaeology from around the world. One way we do that is by recording interviews with our hosts and guests located in many parts of the world all at once. We do that through the use of Zencastr. That's Zencastr. Zencastr allows us to record high-quality audio with no stress on the guest. Just send them a link to click on, and that's it. Zencastr does the rest. They even do automatic transcriptions. Check out the link in the show notes for 30% off your first 3 months, or go to zencastr.com and use the code Archaeotech. That's ARCHAEOTECH. Looking to expand your knowledge of X-rays and imaging in the archaeology field? Then check out An Introduction to Paleoradiography, a short online course offering professional training for archaeologists and affiliated disciplines. Created by archaeologist, radiographer, and lecturer James Elliott, the content of this course is based upon his research and teaching experience in higher education. It is approved by the Chartered Institute for Archaeologists as 4 hours of training. That's in the UK, for those of you that don't know. So don't miss out on this exciting opportunity for professional and personal development. For more information on pricing and course structure, visit paleoimaging.com. That's PALEO imaging.com, and look for the link in the show notes to this episode.
Hi, welcome back to the Archaeotech Podcast, episode 118. We're continuing our discussion with Kelsey Reese about work that she did in the Mesa Verde Cuesta. Kelsey, right before break, I kind of teed up a strange question for you about the tools and about how you're modeling, the communities, and so I was just wondering, why do you think, and how do you think computer modeling is appropriate to explore human behavior and social relationships?
Yes. So I think we have a really great opportunity with the computational power that we have today to kind of tease out different things in the past. And I think that, computer modeling, you have to think of on a very large scale. It's very zoomed out. It's difficult to pick out or explain very individual behavior with those tools. And they're certainly going to miss the individuals that chose to take a different figurative path. But the repeated social behavior that we see with people, it leaves a physical record, right? Like we actually see, the buildings that are produced. We see in, cases, the paths that were, physically walked across. And so that repeated behavior leaves a measurable physical space that we can identify and use to think about social relationships and human interaction and the human experience in those spaces. So with this paper, a lot of it is based on least cost analysis. And, there's plenty of critiques of least cost analysis and what it includes and what it doesn't include, but it still accounts for, general human universals of like, it's harder to go down a cliff than it is to walk up a gentle hill, and so we can start to kind of tease out those behaviors at a large scale. And then we can work on, adding in other things that might have affected how people moved across their landscapes, like, like thinking about other social relationships, or maybe, enemy territory or something like that, like places that you would either gravitate to or avoid, depending on what is actually going on in the landscape. And that, of course, is, those things are harder for us to see archaeologically, but if we kind of get a basis down of kind of how people are moving and how they're moving about their social space, we might be able to start teasing out those more complicated aspects of that human experience.
What specific aspects in this large scale analyses do you think really reflect human experience? Obviously, travel time is the one that you've been talking about mostly, and you're talking about various social aspects. Are there certain things that you wish that you could look at that you haven't been able to, or are certain things that you think you can with the right data?
Are there certain things that I wish I could look at? Everything.
The answer is yes, right?
I'll answer yes, everything. I'll take anything that I can get. I think what geospatial analyses are really starting to do in a very strong way is we're starting to place the human back into the landscape that we're assessing. Mm-hmm. And there's been, critiques of GIS for decades now about kind of this separation of the human experience and then your, two-dimensional GIS interface that is no real reflection of the landscape that you're studying. And I think the idea of being able to account for the interaction between humans and their landscape on a regular basis and even on a larger basis. So things like a phenomenology, approach where you're thinking of larger scales of, the horizon and what different peaks might mean, and the accessibility to those special places, are all thinking about how an individual is actually experiencing the space that they're in. And I think that those analyses become much more powerful in their explanatory power than just kind of measuring distances or simply like mapping things out.
Right.
Yeah. So I think that I think these really large scale analyses that are being done more recently are really exciting because you're starting to kind of add in that socialized aspect or trying to really tease out the experience of an individual as they're standing in a space, looking around and deciding, like, do I need to go grab water from this spot, or am I going to go, talk to my neighbor, and what the implications are then for the archaeological record and what we ultimately see based on those decisions being made.
Right. So it's not just kind of blind mapping of automaton on a landscape given certain parameters, but it's trying to get at the ways that people actually interact with those different parameters as humans,
exactly,
with our various motivations and demotivations that we have.
Yeah, and certainly doing these large models that we have of putting in inputs and looking for protein need, and like I said earlier, I was part of the Village Eco-Dynamics project, and they created an incredible, large, complicated model that looked at, human behavior in the Mesa Verde region. And I think all of that is certainly necessary and has done a really good job at answering a lot of questions that we've had. But now because that is out there, at least in, my area, then we can start kind of picking apart little pieces of it and asking very specific questions, because we already have that kind of baseline idea of what's going on in the environment, mm-hmm. and with people aggregating and disaggregating through time.
All right, well, let me switch gears on you a little bit here and ask you. You were mentioning GIS. I don't remember actually seen the term GIS in the article. If it was, I missed it or forgot it. It's not foregrounded as, these are the tools I'm using, but obviously it played some part of the tools that you were using. And since this is, after all, the Archaeotech podcast, and I work in IT, what tools for GIS or GIS-related tools were you using for mapping and statistics?
So I actually did the entire project in R. Which is probably why I never actually mentioned GIS, which I hadn't even thought of until you just brought it up. But yeah, so everything's done in R. My whole analysis is all scripted and available. I put a reproducible script up on my GitHub. So if anybody has a data set that they think that this might, that this might work for, I welcome them to copy that code and try to make it work for their area. And yeah, so I think that creating reproducible work and creating it using tools that are freely and openly accessible to people, to researchers around the world, whether they're, affiliated with a university or, doing research on their own, is incredibly important. So everything that I do, I try to do in, free and open source software, and then try to make that as available, or at least as transparent. Even if I'm not posting reproducible code, I'll still put my code up there to make it as transparent as possible of what I'm actually doing to come up with the numbers that I ultimately present.
That's great. I mean, I've been at IT for so long that I'm really pleased that so many people have that same sort of attitude about their about the tools that they use, the code that they write, the algorithms they use, whatever they devise, and that they want other people to see them, use them, fix them, make them better, and so on and so forth. So, do you mind? Will we be able to link to that GitHub account of yours in the show notes?
Yeah, absolutely.
Oh, good. I'm going to want to take a look at that, because that sounds interesting, even though R kind of makes my skin crawl, but it's a mighty useful tool. As programming languages go, that's one of the ones that every time I look at it, I'm just like, this is backwards. Why do you do it like that?
Yeah, it's so funny. It's really it's the first scripting language that I really learned. I used to clean Java code for my dad when I was little. So I guess that was technically my first introduction. But one of my good friends, Dr. Kyle Baczynski, we worked in the same lab together during my master's degree, and he kind of set me up and got me going. And I just had this moment where I realized, oh my goodness, I can do anything I want with this interface. Any type of analysis, anything that you want to do, you can do it in R, or you can find a package that will do it for you in R. And it's a really powerful tool, and I would highly recommend anybody using it, despite what you're saying.
No, absolutely. I recommend everybody take a look at it. I've tried to use it myself a bunch of times. I don't have data that are really amenable to it. So,
that's totally fair.
If I was doing archaeology full time, then yes, I'm sure I would find a great use for it, because it really is powerful. So thanks for sharing that. But that's interesting. There is kind of an RGIS divide, not really a divide, because they dip toes in each other's waters. Same, like there's also Python in R. I see that as kind of
you can also run
friendly competition.
Through R.
Yeah. So it's different communities. I'm sorry to use that term of archaeological tech geeks, I guess. So sorry. Another technical question I had is that, in your article you cite, and you did here on the interview today, different prior studies that you're using for your population estimates. And definitely anybody that's interested in such things should read your article to get those references. But since you're plotting these things on a map, what map sources did you have? What data sources did you have for your mapping?
So the maps themselves, the landscapes are all just downloaded from USGS, the 10 meter DEM.
Right.
The site data itself is from the VEP, or the Village Ecodynamics Project. All of that information was basically was kind of like a big data pull from the Colorado site database. And so the VEP database is actually much larger than what I'm using. I probably use, I don't know, maybe, I don't even know how many total sites through time, but it's a really small subset of, I think there's like well over 10,000 sites in that database that are for the entire Montezuma County area. And I just use, the sites that are just on top of the uplift in Mesa Verde National Park. So it's a really small number. So that's where all that data came from.
Great. One other question, and this is back more towards your article. You are dealing with a fairly long span of time, and with households. I'm hoping that are defined by buildings that have variable lifespans. So you talk about in the article momentizing your data. That is like dividing into snapshots, I guess, of certain times, so you can seriate it and then and run your analyses on not everything in a 150-year time span, but things that would have been contemporaneous in that 150-year time span. That I thought was a very interesting part of the article, and also a lot of it went over my head. Do you want to briefly describe how you did that?
Yeah. So momentizing households is kind of the thing that I get asked about most in relation to this article. And it's this idea that, we already have really high resolution time periods in this data set, but those time periods still are not small enough to represent the individual use life of residential architecture. And so for example, in our first time period, it goes from AD 600 to 725. It's 125 years. It's our longest time period. But during that time period, the average residence was probably only used for about 8 years. So if you assume that all of the sites that we have that are dated to the 600 to 725 time period were occupied contemporaneously, we would have over 1,000 households for that time period. But it's just not the case. There were not 1,000 households living on that time period, or on the Cuesta during that time period. It was in fact the least populated time period. And we just know that from, kind of general population estimates of the Mesa Verde region. So we know that that's not right. So momentizing the households is this idea to try to make the total number of households occupied contemporaneously more representative of what was most likely to be the case. And so it's just this idea of taking, so if we have a time period that's 125 years long and our average residence lasted 8 years, we divide 8 by 125 and then multiply that with the total number of households we have to that time period. And so for our first time period, the 600 to 725, that would leave us with 62 households that were likely occupied contemporaneously versus about 1,000. And so to then run the analysis on that, I basically did a random selection. And so I had the list of all 975 residences and said, okay, randomly select 62 and then run our cluster analysis on it. And so it's not a perfect solution because, you could have had really dense clusters of households. Maybe there were 62 households being occupied, but they were all occupied on one mesa at one time. And then, they moved to the next or whatever through that 125 years. But it was the best kind of solution that I could think of on this scale to try to best represent what was going on. And so, so the residences have a shorter use life than their corresponding time period from AD 600 up until 1100. So, and that's more than half the time in the study. So for all of those periods where there's this discrepancy, I repeated the process 5 times each, and then averaged those results together to just try to get a most representative sample that I could to give us the best idea of what was going on at that time.
Right. So 5 times 5 different random samples
Yes.
of the, for example, those 62.
Yeah. And then of course it created, 5 different groups of communities that were all different because, they all were based on different residences. And so, actually every single result from all of those runs is actually posted in the supplemental material online. So you can actually see the differences between, each of those 5 results and how they work for the different time periods.
And run the maps, I guess, and the stats again yourself with the with what you've posted on GitHub, I take it, right?
Yeah, feel free. But if I did something wrong, please let me know.
I wouldn't be able to suss it out, I'm sure. Why don't we take a break and then we'll come back for a brief wrap up. See you in a minute.
You may have heard my pitch for membership. It's a great idea and really helps out. However, you can also support us by picking up a fun t-shirt, sticker, or something from a large selection of items from our TeePublic store. Head over to arcpodnet.com/shop for a link. That's arcpodnet.com/shop to pick up some fun swag and support the show.
Hi, welcome back to the Architect Podcast, episode 118. We're having a great interview with Kelsey Reese, and because Chris isn't here to talk about Apps of the Day, I decided that we're going to have a special extra third segment here to wrap up our discussion. So, Kelsey, you were talking about some of the tools that you use, R in particular, and there's a whole crop of different tools that people are using nowadays for actually getting data for archaeological purposes, for landscape studies in particular. Is there anything that you have used or would like to be using, drones, for example, because I can't go through an episode without mentioning drones. You're welcome, Chris, that are going to be of use to you in your further studies? Yeah,
so I think the availability of drones nowadays is it's phenomenal. I mean, the amount of technology that's packed into these increasingly smaller and increasingly cheaper little things that you can throw into your backpack is incredible. And I think that drones, as far as collecting landscape data, are going to really revolutionize how we can think of spaces. And I say that because, as I was talking earlier, I was talking about, how these large-scale geospatial analyses are starting to really incorporate humans, the idea of humans in these spaces, and that I think that that's a good direction that we're going in. And I think drones are kind of how we get there. And I think what they provide is the ability to collect data on a human scale. So we're able to answer questions about the human experience because we're able to capture data on that scale. The types of terrain models that we're going to get from drone, even just photogrammetry, are way more detailed, and you can learn a lot more from them than you can, the 10-meter DEM that you're pulling down from the USGS. Mm-hmm. So I think that right now we're in a very we're very excited about the technology as a discipline, and we're doing a lot of things that we're producing a lot of publications that are strictly about producing data. How do we make data from drones? Mm-hmm. And I think that the really powerful next step is going to say, okay, but what can we do with that data that we're producing? And so it's starting to run, kind of the same analyses that we're used to. You can do least cost analysis, you can do hydrography, visibility, other site level studies that you can get much more resolution. And I don't necessarily mean like pixels per centimeter resolution, but the idea is that it's much more at that human level scale, where if somebody was standing on that landscape, that would be their experience in those spaces versus, something that is a much lower resolution. And so, so I think drones are really a great tool that are going to fill that gap and provide us with a whole host of information and ways to understand archaeological landscapes that we just haven't been used to so far. And it's going to be really exciting to see what comes from it.
Yeah, well, there's certainly been a crop of a lot of very interesting studies that are showing, if nothing else, just new ways of mapping archaeological sites with drone data. I'm sure you're right that it is going to allow us to piece together various kinds of different kinds of data, and also data at various scales that we haven't always had access to.
Right.
So, we're definitely, architect Chris and I are both definitely on Team Drone. Before I go too far afield here, your study found, the one that we've been discussing so far, found that there's a fundamental shift in those communities and how the societies are organized in the 13th century AD. Do you want to describe how you found that, how it showed up in your models, and what you believe that reflects?
So what I think that you're referring to is the area per community.
Mm-hmm.
So one result that we had that popped out that was completely unexpected was this sort of equilibrium of area per household within a community.
Uh-huh.
So the calculation is basically we have our cluster of sites that are grouped into a community from our cluster analysis, and I would just put what's called a convex hull. So straight lines around the outermost points that surrounds all the other points. Determine the area of that, and then divide it by the number of households, right? So you get area per household within a community.
Right.
And so what we actually see is that that area, it ends up settling right around the amount of area per household that you need to farm to support one household for each year. And as populations increase or decrease on the Cuesta, that metric either stays the same or it kind of, it gets a little screwy for one time period, but then it returns to that same equilibrium point. And then the kind of that changing point, the point of no return almost in the 1200s, right before the area was depopulated, we had the most number of people on the Cuesta at any time in the previous 700 years, and people are having the least amount of area for farming within their communities. And so, as the environment was, wasn't the worst it's ever been, but it was certainly unstable and very volatile. And then you had more people coming into the Cuesta. I mean, even as the population in the Mesa Verde region as a whole was decreasing, the population on the Mesa Verde Cuesta was still increasing. So you're still getting people coming on there, even in the worst of years. And they're starting to see a huge drop in the amount of land that they have available to provide, their annual food need. So it was kind of this really interesting little, metric that came out that, I wasn't expecting to see. I just thought it would be interesting to look at that trend through time, but it really does kind of create an interesting spot where you can see where people are really kind of unsettled and getting unhappy in their area right before that area, the Cuesta itself is depopulated.
Yeah, interesting. I found that actually quite interesting. I'm using the word again. That it was like stressing on an already stressed system, and people stop, like you said, stop reverting to that equilibrium, and then it all just falls apart, like one push too many. Yeah,
and earlier in that time period, if there's more people coming onto the Cuesta, you could kind of spread out in your communities, or the less people you could squeeze in. And they were able to kind of maintain that. But I think it just got to the point where you're having too many people packed into the same little space, and it just became unrealistic to maintain that annual food subsistence.
Right. Well, to round out our conversation today, thanks for taking your time to talk to us about this. I thought it was a very interesting use of tech to look at how people in the past lived. You said it before, this was basically your MA research, and now you're working on your PhD. What is your dissertation research on?
Yeah, so this whole time we've been talking about the Mesa Verde Cuesta, the landform itself, but my dissertation research actually is focusing on what we call the Mesa Verde North Escarpment. So on the northern edge of the Cuesta is a 600-meter cliff face, and everything basically north of that slopes down into the valley to the north is the escarpment. And so it's this really interesting area that has generally thought that there's not too much going on. Like the general idea has been that it wasn't really heavily occupied. There wasn't too much going on in that space. And it's really just because, when you look at a plot of sites across the Mesa Verde region, it's just kind of generally empty. And, that idea can be totally explained away about how it's, it's a weird area. It's very vertical. It's north facing versus, the south facing slopes of the Cuesta, where you get longer sunlight, warmer temperatures. So it kind of has a lot working against it. But if you talk to anybody that's ever worked out there and did any survey, they would tell you that it was some of the most densely occupied area that you've ever seen. And so what I've been doing over the past 3 summers is going out and I'm working with the BLM. So it's all it's outside the national park. It's all BLM land, and so the local field office there. And we've been doing pedestrian survey, and so kind of filling in that knowledge gap of what might be out there. And we found that it's got some huge communities going on. And it's really quite exciting. We've found 4 pretty aggregated, very dense communities across the front of the escarpment so far. And they're all evenly spaced. They're all have a P2 occupation component, so about 8,900 to 1,100. Most of them go into the P3 period, so 1,100 to 1,300. But they're all basically contemporaneous. They're all basically evenly spaced from each other, and there's a lot of evidence to show that they're really harnessing the water runoff that's coming off of the front of the escarpment. So if we think of, it's north facing, so it might be a tough place to live because you're not getting as long of growing seasons. Well, that might be true, but you're also getting all of the water runoff off of the entire cliff face of the Mesa Verde Cuesta. So you might be able to, you have a little bit of an advantage that way by channeling that water. And so,
right.
There's lots of control features out there that, like I said, there's pretty dense communities. And so that's kind of what I've been working on over the past few years, just for field work. And then the idea is that all of those sites, that whole survey is kind of going to get funneled into answering the question of looking at the long-term effects of climate change over subsistence farming communities. And so the escarpment data set will basically provide a 700-year longitudinal study of how people are responding to potentially volatile environment when their food is just, they're completely subsistence-based communities. So that's what I'm working on now.
And I assume you'll be using a similar tool set, going back to R to help model some of these.
Yeah, it'll all be done in R. How'd you guess?
Shot in the dark.
Yeah.
Well, not going to take up any more of your time today, but Kelsey, thanks so much for coming on. Very interesting discussion. I learned a lot today. Best luck with that dissertation research. We look forward to seeing what you do with that.
Excellent. Thank you so much for having me.
No, thank you. Take care. Thanks for listening to the Archaeotech podcast. Links to items mentioned on the show are in the show notes at www.arcpodnet.com/archaeotech. Contact us at chris@archaeologypodcastnetwork.com and paul@lugal.com. Support the show by becoming a member at arcpodnet.com/members. The music is a song called Off Road and is license free from Apple. Thanks for listening.
This show is produced and recorded by the Archaeology Podcast Network, Chris Webster and Tristan Boyle, in Reno, Nevada, at the Reno Collective.
This has been a presentation of the Archaeology Podcast Network. Visit us on the web for show notes and other podcasts at www.arcpodnet.com. Contact us at chris@archaeologypodcastnetwork.com.
Thanks again for listening to this episode and for supporting the Archaeology Podcast Network. If you want these shows to keep going, consider becoming a member for just $7.99 US a month. That's cheaper than a venti quad eggnog latte. Go to arcpodnet.com/members for more info.